years, users are able to get the SMS free of charge. Just contact me or our SMS help desk with ERDIC, and we'll get you started on that. The CMS basically is composed of two different types of models. We have a wave model and a flow model, and they work interactively, passing information back and forth to accomplish the simulation that you want to do for whatever time period. There's various features for the waves and the flow, and they're listed here. We're going to go over this into a lot more detail in a few minutes. And the CMS fits into this blue oval on our time scale of coverage. So it works anywhere from seconds and minutes up to multi-years, not quite to the decades part, and then also from very small scale to larger scale. And we actually have some grids that we've been doing that are up to 60, if not a little bit larger, 60 kilometers. So we're getting to be larger and larger time scales and spatial scales. And so hopefully eventually we'll be able to model pretty much anything that the user needs to within reason. So the SMS is all of these things. It's a preprocessor for organizing your files, bringing in surveys, bringing in CAD data in the form of shape files or DXF files. It also works as a post-processor after the model is completed so that you can visualize your results. You can create plots and film loops, do different calculations on the answers, and get ready for another actual simulation later if you want. And then can also connect with these outside tools, CAD, GIS, any type of ASCII columnar data, and images can be brought into the SMS. I'm not going to go into all of this. It's going to be explained over the next few slides. But basically there's various parts of the interface. There's a menu bar, edit window, graphics window, and you'll see that in just a few minutes. And then I'll actually get into the interface and show a little bit about these. The modeling suite, as is shown here, we have anytime you bring in data, it'll appear in this data tree, and it lists pretty much everything that you have loaded, and you can easily click from one to another to change to that particular data set or to that grid, to that form of data. Anytime you make any changes here to what you're looking at, this graphics window may show different scalar contours or vectors, but this pretty much shows whatever is selected in the data tree. If you have time-varying data, such as a simulation result that you've loaded in, then you're also given a time step window that you can scroll through and see the changes through time in your graphics window as well. There's a menu bar that does various different things. We'll go over some of those. An edit window for editing particular values, and then changing some modules, and even help and some status information. For the toolbars that are used, there's a couple different kinds. There's a static toolbar that pretty much these tools stay exactly what they appear to be no matter what's loaded. They're always there, and they always do the same thing. There's another toolbar called the dynamic toolbar that's usually located vertically, and this will change depending on what type of data that you're working with, whether it's Cartesian grids with rectangles and squares, or if you have scatter points or finite element, triangular elements. These tools will change depending on what is selected over here. When working with Cartesian grids, which is the type of grid that CMS-Flow and CMS-Wave both are, we work with cells, rows, and columns, and there's tools to handle each one of those. Basically, if you see an arrow pointing to a certain element in these icons, it means it's a selection tool and not a creation tool. And so if the arrow is missing, then it's actually used to create most of the time. There's other tools for splitting rows and columns if you're working with a variably spaced grid, moving those rows and column and row edges, creating cell strings, which is what we use to bring in boundary conditions, creating your frames, applying labels. Scatter data is how we bring in bathymetry and different types of other information, and you can create, move those points around, flip the edges. There's other ways of working with other types of data through the map module as well, and I'll go over some of these throughout the course of this seminar. The data tree, like I said, pretty much holds everything that you have loaded, and if you save a project in SMS, then it saves everything that's listed in that data tree so that you can bring in one file with a .sms extension, and it loads everything how it was the last time that you saved, even down to where you were looking, what your scalar contours were, what projection you had set, things like that. It makes it easy to switch from back and forth. Before the data tree existed, there was 3 or 4 different keystrokes that you needed to go from one thing to another. It was just so complicated. It was hard to use. So this has made it so much easier to work with your data. We try to use SMS to build a complete model from start to finish. So the first part is bringing in the background data, which could be your channel surveys, bathymetry, aerial photos to help make sure that you're in the right projection. Even coastlines can be brought in and converted over to a format that can be used to build these grids. Then once you have all that, you can build a conceptual version of your model, which just means I want to define what the domain is, what bathymetry will be used to build that, and then actually placing points and polygons to add resolution and things like that. Then actually, once the grid has been created and everything is set and ready to go, you can actually run your CMS model and then later on visualize the answer. And here's just an example of that. So we work with bathymetry in the form of scatter points. So they're just triangulated points that brings in the information that you need. And that's the underlying way of getting the bathymetry into your grids. Basically, if you can bring in a columnar data file, ASCII, it's the easiest way to bring in information into the SMS. There's an import wizard that kind of helps, and it brings these things, the columns in, and lets you assign different attributes to those columns. So in this example, we have 6 columns, and we have an X, a Y, and a depth. We also have other values here that it's brought in. We can associate a name and tell it what kind of data, whether it's scalar or vector information. We can bring that in as well. It stores spatially varied data. Most of the time it's bathymetry, but it can be other things, sand samples or anything else like that. And then it helps to interpolate that information to the various grids that we use, whether it's the flow grid or the wave grid or any other type of numerical model, if you're using AdCirc or some other model in the interface. You can visualize the data. You can add, look at it obliquely. You can add a shading to make it a little bit more evident what your area looks like. We'll be going over some of this. You can fill the contours. You can have linear contours if you want. It's very easy to do pretty much whatever visualization that you might need within this interface. You can bring in Lidar points. They're usually very dense, and so this kind of shows you, the area and how they're coming in. These are much more sparse and very dense in these areas. So we're able to take in these large files and decimate them a little bit, work with them a little bit more easier, and then save that information back out. We've introduced breaklines, which help to better delineate our channels without worrying about the elements crossing that channel and blocking the flow when we actually build the bathymetry for our grid. And so when we work with these scatter sets, they come in one by one and populate the Project Explorer over here, the data tree. And so each one has various options that you can right-click and get to. And we may cover a few of these today. And then you can take scatter sets and surveys for different areas and then merge them all together into one big bathymetry file, and that's what the CMS uses. It operates with points and triangles, and so in this case we have a survey set and we have no points where there's this barrier island, and so we have these long triangles that cover the barrier island, and then we can go through and delete those out so that we get we don't get that transition of information over this area, and we could supplement that with an actual topography information if we had that as well, and merge those together. We can bring in topographic maps or aerial photos. This link, I believe, used to be valid, but it has now been taken down. They're now wanting to charge for all this information. This was a really nice site to be able to go to, and there's even links in the SMS interface that use that so that whatever area you were looking at, it would be able to go out and get the exact maps, topo, aerial, and even some urban photos for that zone. So unfortunately they started charging for that information, and that site's no longer working. You can overlay your data that you're working with in the interface onto those images, and this kind of helps when you're presenting this to a customer so they can see what area they're in. Gives a little bit more information rather than just that data. And since we're working with the CMS-Flow and CMS-Wave, there are various pull-down menus that are geared only for our needs for these features. And so I'm going to go through a little bit of this right now. A lot of these options are the same between the flow and the wave grid, mainly because they're both finite difference type grids. But for the CMS-Flow interface, we have data. We have a steering module link, and that starts the interaction between the flow and the waves. So you can tell the interface that you'll starting a run that's going to go back and forth between the two types of runs at, say, a 3-hour interval or a 1-hour interval, something like that. Specifying different information, it'll actually start that run for you. Data calculator is where you do some functions based on your data sets. There's other operations that are considered within the Dataset Toolbox. We'll go into some of this a little bit later. There's vector and contour options, film loop generation, and converting your grid that you've created back over to scatter point so that you can get it into some other type of format. There's also cell string menu, and like I said, that basically cell strings are needed to force the model, so we assign a water surface elevation, different types of boundary conditions to those cell strings to actually force our model. Then you can actually set up in the model control, set up the parameters and different options for running the CMS flow. and then actually start the model running from within the SMS interface. Various parameters on the Model Control tab. This is changing a little bit with the next version coming out. So, but right now in version 11 of the interface, we have model parameters, starting time and date, hot starting information, various other parameters for when to begin wetting and drying your cells. And there's a few other controls that we'll go over a little bit later when I get into the CMS portion of the overview. The CMS-Wave interface is basically the same. We have the steering module, data calculator, film loop, grid to scatter point. But then there are other options that are only available for a CMS-Wave type grid, which means your spectral energy, how you're actually forcing those waves. You can build a child grid for a large domain wave grid, and then various controls and checks, and then actually start running CMS-Wave as well. In the spectral energy, this is just an example of what the screen might look like. It's showing the various times that we've associated with wave characteristics. The wave model it runs discrete instances of the waves. And so you just go from one to another, and then you can see the change in the direction and the intensity of these waves from the screen. Or if you don't have a real spectra from a wave gauge, you might be able to enter the bulk criteria for that, which is just consistent of the wave height, period, and direction, and some other spectral parameters as well. For the model control for waves, this is what that screen looks like right now. We've got wetting and drying, some reflection options, friction, diffraction intensity, what type of information will be used for generating the waves, whether it's coming from wind or spectra or both. And we actually have what's called a simplified formulation, a fast mode, if you will, for running the waves much faster. It gives an approximate answer that's much easier to get than the full wave. And then different types of output for the wave model. Other things that have been added recently to SMS, SMS 11's been out, I guess, about a year, maybe a little over now. They've made some changes. If you had used version 10.0, 10.1 of SMS, some of these will look a little bit different. We've got the Dataset Toolbox, which is new. It includes the Dataset Calculator, but there are other tools for sampling data. I'll show an example of that in a minute. We've got grid duplication, spatial data coverages, different types of plots you can do, and working with projections a little bit easier and in a more standardized way in relation to how this works like GIS and some other tools do. For the Dataset Toolbox, this shows all the options that are presently available. This may increase in the number of tools that are available. You know, it may have more than this now. But basically, these are the ones that we use most often. So we're looking at comparing two different data sets, making operations within those data sets with the calculator. We can take a very large or long simulation run and sample those time steps so that they match up exactly with another simulation so that we can do a one-to-one comparison between the two. Converting scalar information to vector. If you have the magnitude and direction, we can create a vector or vice versa, and then some other tools. There's a web menu that is available, and like I said, you could import images from that server. It may still be operational for a few more weeks, but I think the deadline for that closing down was June or July of this year. We have other ways of finding some data and even links to some filtering tools that will be available as well. Spatial data coverages is a new module in the SMS interface, and it basically lets you be able to take some wave information or wind information, specify a gauge, and build a compass plot or a wave rose, a wind rose, to get more information from the data that you have available to you. This shows a compass plot. Basically, it's linked to a certain location where the winds are, and as the simulation is running through an animation, this vector will grow and shrink in intensity, as well as the direction will be changing as well, depending on the direction, of course, that it's coming from. The same thing goes for waves as well. There's coordinate projections. It's basically the same as it always has been. They just changed the wording from coordinate system to projection, and they've added in a few more different types of projections depending on what part of the globe that you're in. Also, I've added support for projection files that come out of GIS and CAD. So if you've been working in your other programs and you've saved your shape files and this information, you can also save the projection as well, and it'll automatically be loaded and brought in once you load that to the SMS. For post-processing, we can generate annotations and graphic images, some different film loops and animations, and export those all out to KMZ, KML type files, which works with Google Earth. So that's a real nice way of showing your results in Google Earth as well. You can see 2D plots, time series, and profiles, cross-sections, various different ways that we can use these plotting packages within the SMS to analyze some of our results. Annotation layers, it's basically a layer that they have in there where you can insert a north arrow. You can put in logos, you can put in a scale bar, things like that. The nice thing is these north arrows now are linked in space, and so if you change the orientation that you're looking at your grid at an oblique angle, that north direction will change as well. You can vary the different ways of looking at your results, whether it's contours and vectors. You can look at them filled or with lines, or a combination of both. Change the size of your arrows depending on how large the data is. And then all of that, like I said, can be exported to overlay onto Google Earth. Even the animations will run within the Google Earth framework. So like I said earlier, if you're interested in using SMS beyond the 2-month period that we've given, I guess a month and a half at this point, contact us back here, either myself. If you work for the Corps of Engineers, then send an email to this email link right here, and we will forward a license to you guys. If you're not a Corps of Engineers employee, then you'd have to talk to Aquaveo, who's the vendor for SMS, and you can request another evaluation or talk with their sales team about purchasing. And there are significant discounts as well for academic licenses. If there are any questions, please submit a question to the interface, and we'll try to answer them real quick. Otherwise, I'm going to move on to CMS and do a little overview of that as well. Okay. So for the coastal modeling system, it's been around for a little while now. It's gone through a few version names. It was once called M2D, then we changed it to CMS, the Coastal Modeling System. There was a flow model, then there was a separate wave model. Now we've integrated both of those into one code and kept the name CMS for that combination. In the very near future, we'll be adding in not only the implicit flow model, but the explicit flow model as well. Right now, the explicit is a standalone code, and so we'll be working to get those together for the users, so there's not 3 or 4 different versions of the code out there that people are having to switch between. So hopefully that will make things easier for you guys. CMS-Flow, like I said earlier, it governs the hydrodynamics, the sediment transport, morphology change. There's a simple salinity transport as well as some other features that we're working on implementing. There's a CMS-Wave, that's a half-plane wave model. It also has a full-plane wind forcing, so that if you have winds coming in that oppose the direction your waves are coming in, it can handle that. I'll be going over that in a little bit. The objective for SERP's use of CMS was to deliver in a practical way to the engineers so that they can use it on their desktop. A code that they can run, or we can run, or they could look at our results, just so that it's easier for the engineers to work with. There are several codes out there that can only be run on our high-performance computers, and that's fine, but for the most part, we wanted to deliver a different type of package that is more available to everyone, not just the ones that can use the high-performance computing. So our goal is to get all of these done most efficiently, working together in an interface. We also provide different manuals and technical reports, journal papers that we submit, and we have a documentation portal through the wiki so that we can assist the engineers with any questions they might have. As I said earlier, I gave this little topic here. I didn't go over the other side. We started the Coastal Inlets Research Program in 1997. Until this year, we had done 35 workshops and 1 webinar. Now we're at, this is the 2nd webinar. The first CMS, the other one was on GenCade. And we've done 2 or 3 workshops since this slide was originally produced. The advantages for CMS is it's very robust and it's physics-based. It's integrated together, the waves and the flow, and into the SMS interface as well. And it's reasonably user-friendly. We're trying to add new features to the interface now and then, excuse me, so that we can better handle the things that are being added to the CMS, so that it's easier handled by the user. For CMS Flow, the key features of the model, it uses a finite volume method. It conserves mass both locally and globally. It's very stable, considering if you are running the implicit, it's very stable. The explicit is very stable as long as you don't violate the current condition for your area. It's easy to use. It's very accessible. We have our versions listed up on the website, both this one and a couple of past versions as well, if you're still using those. It's coupled now with the Spectral Wave model, CMS-Wave, that better handles the wave and current interactions so that your waves can modify the currents and vice versa. It has an inline sediment transport morphology change. We've implemented a non-equilibrium sediment transport model, which is a little bit different than how we've always done it, but it makes the answers much more reasonable and hopefully easier to get the right answer. We have nesting capability. We can force with water surface elevations, river flows, wind, atmospheric pressure forcing, and then also we've recently added in the ability to specify tidal constituents as determined by NOAA at various sites around the country. So that's very new, and we're working on implementing a more thorough version of the tidal constituent forcing as well. So that's coming up. There's two different types of grids that are used for CMS flow. The first one, which has been around since CMS has been in existence, is this variably spaced grid. So as you see by the graphic here, in the I and the J directions, you could increase resolution, but that resolution had to be extended all the way to the domain. So you would end up with very small cells at deep water, which caused a little bit of problem and extra calculations that had to be taken into consideration. So in recent years, we've also added in a new way to do this called quad tree grid. It's sometimes called telescoping grids. And that allows us to increase the resolution only in the areas that we really need it. So in this sample, we have increased resolution around the jetties and the revetted areas. Then we have another level of resolution in the inlet throat and along the shoreline. And then it gradually increases in resolution until you get to the deep water. And each one of those steps is doubling the resolution. So if you have 50 meters out here, then you'd have 25 meters in here. There's also two different solver options, which I alluded to a second ago. One is the implicit model and one is the explicit model. And basically that's a difference in the way the solutions are calculated. With the implicit model, which is relatively new, we can have time steps anywhere from 5 minutes, maybe a little bit less, up to 30 minutes or an hour. We don't really recommend running much larger than a 30-minute time step. But this is much better than running as the explicit did with around 1 second to sub-second time steps. There are some situations where you may still want to run the explicit model, and we're going to keep that available for a while. And both of those solver options are able to use the different cores on today's PCs so that you can run even faster than running one processor at a time. For hydrodynamics, we have a depth average current velocity that's calculated. It uses the total water depth forcing with water surface elevations, different types of other forcings. There's gravity, atmospheric pressure, precipitation, evaporation is coming in, if not already there in some versions of the code. We do have Coriolis. We calculate eddy viscosity. We have a bottom stress that also includes the wave effects. We also force with wave stresses when the information comes from our wave model, and we can also force with a wind stress as well in various different formats. Just one example of a grid that we've set up in the past in Packery Channel, Texas. So this is the area here. It's a pretty difficult area to model because of how shallow this area is over here. But we were able to get this up and running. We did some initial validation. This isn't the final validation, but this is relatively quickly. And this shows a little example of how you can do some of the plots within the SMS as well. Both the scalar values like water level and the vector values, velocity, at 2 different points. I mentioned earlier nested grid capability. We've got a larger grid here that you can force with either a tidal database, such as the 2 EDSRC tidal databases, or there's a global Le Provost tidal database that is out there. So you can specify an area to be forced by those tidal databases, and then if you want to run a smaller grid, you'd create that and then extract the information directly from this solution to be used with the smaller grid. And you can get not only the water surface elevation, but also the U and V velocities as well as the water surface elevation. Some of the key features for our wave model, it has shoaling and refraction, diffraction, and reflection. There's bottom friction, of course. We have capability to take into account white capping, 4 different options for wave breaking calculations, wind generation of waves. We also have wave current and wave-wave interactions, transmission, run-up, and overtopping. There's calculations you can do for using muddy bottoms. I'll go through that in a few minutes. There's automatic grid rotation, which we had issues if you want to use the exact grid that you used for your flow grid. We had previously some issues building those, so we have that automated now, so it's a little bit easier. Using the wave model uses the non-uniform Cartesian grid, basically variably spaced, not the telescoping grids. I'm not sure that that will make it into the wave model in the near future, but maybe. But right now we do have the variably spaced grids. And as I mentioned earlier, there's also that fast mode or simplified formulation of CMS-Wave to run about 5 to 7 times faster than normal. For calculating wave run-up, we can, it uses the 2% run-up. There's a couple little acknowledgments there on where we got some of the information from, but this is a relatively new addition to the waves, but it can be activated in the model control today. There's wave generation from winds, and so this is an example of Hurricane Rita that came through, and basically as the hurricane comes towards shore, the directions of those winds vary significantly from one direction totally to the opposite direction. And so we were able to model that and get pretty decent results from our waves. So you guys are able to benefit from this research that was done a few years back, and we have the full wind forcing now, full plane, even though we still only have a half plane wave forcing. This wave dissipation over muddy coasts, basically the user is able to specify a certain area and classify that as mud and give it some parameters, and then be able to run, and the wave model will better represent that area, as you see with some of the graphs over here. They're a little bit hard to see. These were taken from a report that we did, but all of these graphs and a lot of information is available in some validation verification reports that we published last fall. Sediment Transport, some of the key features, we have various transport models. There's an equilibrium total load, there's equilibrium bed load and advection diffusion, and then there's a non-equilibrium that I mentioned earlier. And then various formulas for actually transporting the sediment as well. Lensert, Van Ryn, Watanabe, Soulsby. And not each of these will be, valid in your particular area, you'd have to change to different formulas to see which works best in your area. And so we make those options available to you. You can also turn on a hard bottom if you're working in some parts of the country where the sand is really limited once you get down to a certain level because of rock or other types of hard bottom. So you can specify that. We have avalanching. We can change the influence of the bed slope on bed load equations. And then most recently we're adding in multiple size sediment transport. So you can do different types and sizes of your grains. And Alex will be discussing that at next week's webinar. When using the implicit model, some of the computational speeds you can see from these examples here allow us to come up with a much faster answer than with the explicit version. The Shark River case, it only had 33,000 cells, and we got a year answer, a decent year answer too, in 1.3 days. Similarly for Shinnecock with 53,000, just a little bit longer time. And then for this area in France, we got a whole year in only 7 hours. So the implicit model allowing us to run at time steps of between 5 and 30 up to an hour time step has really enabled us to do longer and longer term runs and still get good answers. A lot of documentation is covered both on our website and our wiki that we have. So the website has various menu options and has the actual links to the code. The wiki is reserved for better documentation of the models. And so we have not only the CMS, but several other of our models included there. But there are links to the reports, there's links to all the equations that are used, there's user guides, how-tos. It's a very nice place to go if you're looking for ways to use CMS or need some answers. You can always email us or give us a call. We'll try to answer your question, but you might want to try just looking on the wiki first. It has a place to put in a phrase if you're looking for a certain thing and do it in a search. So try looking there. It's got a lot of information. There's a thing called the CMS documentation portal that is a nice, has 3 big columns that lets you go to different areas. So the website contains a list of all of our products, and here's that list. You can go between the CMS, you can find the different versions, and so if you need the most recent version of our code, this is where I would go to get it. We also list all of our publications that we do each year, and we go back all the way to 1997 when we started the program. So we have all of our CHETNs, conference papers, journal articles, technical reports, and then even links to other articles if we find them informative and maybe useful to our users. There's also technical transfer menu option that gives a link to all of our upcoming and recent webinars, workshops, and various meetings that are coming up. So if you're looking for opportunities to have a little bit of training, we usually update this very regularly. And so, like I said, the webinars, we have 3 listed right now. We may be planning a workshop for the January-February timeframe, and we'll be posting some information for that as we get approval for that workshop. The documentation portal, like I mentioned, for the wiki, We have a column that has all the technical information, the equations, how the underlying model works. And then we have a user's guide, which basically says, this is what I want to do, this is how I set it up in the interface, these are the options, these are the cards that might be written, a lot of information in this section here. And then also examples and applications that we've done in the past. So we have various workshops that we're adding in. As we complete them, we'll put all the data and the presentation material up here. We have links to utilities that can be used. Various tutorials. Here's one on Shark River Inlet, which is a little bit what I'm going to be going over today. Technical information, validation cases with statistics and the underlying equations. We also have information for our other models. GenCade has a nice user's guide that Ashley put together, and also CPT and CSmart. So this one wiki has a lot of information out there, and I beg you to try it out. Also, here are a lot of links to some of our more important versions of our reports and technical notes. I'm not going to go through all of these, but these are just a list of the ones that we've put together over the last few years. So if there are no questions, and hopefully Alex will let me know if I need to slow down or answer anything. If not, I will go to the next section. Actually, I'm going to take about 2 or 3 minutes for a break. I'll be back in just a minute. I'm sorry, guys. I just had a little coughing fit I had to take care of. So, so now I'm going to be going over the next section. There's no questions I see. Let me close a lot of these out real quick. Again, I apologize for all the difficulties we had at the first. This is our first time using this software, and there was a button that I forgot to push. So it'll go a little bit smoother tomorrow, I hope, and the next week, and we'll get much better with this. So, all right. Moving on, we are going to the next section, which is working with bathymetry. And like I said, all of these PowerPoints I've made into PDFs for you guys, and they're linked on our webinar webpage. So as you see my agenda here, each one of these is listed over here, as well as the data that I'm going to be using in a few minutes when I go and do some hands-on demonstration to you guys. All right. So basically, I went over the model and I said how you can use the interface to bring in this data. I didn't really go into detail about working with the data or what types of information, or where this data comes from, how to put it all together. So that's what I'm going to be doing today, and if it takes too long, I may do a little bit more of this tomorrow, but I think this is going pretty fast. There's not a lot of questions right now. I'm sure that there will be some questions as I move forward with this, so please submit your questions. We'll try to answer them, and if I need to, I'll go back and go into more detail for certain topics if I have time. So working with bathymetry datasets and also doing datum conversions. So many times when we're working on a project, we will get information from different locations, from different people for different time periods, and we always want to make sure that we're running with the best information that's the most recent for the area that we're working in as possible. The better the bathymetry, the better the resolution of that bathymetry, the easier you're going to come up with a good answer when you're running the CMS software. So a lot of times we'll come in with different types of bathymetry data sets. So in the cases that I'm going to be presenting today, I have several different types for Shark River Inlet in New Jersey. We have a little bit of limited bay bathymetry that we're bringing in. We have some NOAA offshore surveys. We have an extensive Lidar survey for the immediate shoreline and very near shore. So that's how we resolve our structures at the inlet. And also a little bit of the slope of the beach. That information will come in. We have various channel information, one from the New Jersey State, and then another federal survey that was done. And we also have some other field data that came from the New York district themselves. We'll be merging all those together into one data set. So when you're working with a CMS grid, you have to build it with one source of bathymetry. You can always add in portions later on, but when you're initially building your grid, you want to use one set of bathymetry. That bathymetry should always be in metric, both vertically and horizontally. So we can read in these surveys in feet, but we need to convert them to meters before we use them. The other thing that we need to take into consideration for this particular model is that for the bathymetry, the depths need to be positive. That means that as from the surface of the water, as you go down into the column of water, the values get larger positive values. A lot of times we're working with various companies and they'll give us the data where a higher value is up onto land and above the water, and that's not going to work with CMS. So we have to find a way to convert that from an elevation to a depth. And there's various tools for doing that, and I will go over that in just a few minutes. So there's various interface screens that come up, and I'll go over them as they do for selecting projections and working with vertical and horizontal projections. A lot of the information that we can get comes from NOAA. They have nice benchmark sheets for pretty much every federal location, if not multiple points within that federal area. Here's one that we're using for the Shark River study that was completed a couple of years ago, which is at Long Branch Ishing Pier in New Jersey. And so it gives the relationships between the various datums that you might encounter. So there's a mean lower low water, which is what a lot of hydrographic surveys come in. at least the older ones. The newer ones may come in NAVD88. It may be coming in mean tide level, mean sea level, something like that. And we have to know what the relationship between those so that we can make the datum conversions as needed. So this gives the information between the datums so that we know what that relationship is. So what I normally do in for a project is when I start out, I'll go and I'll gather all the different information that is available out there, and I'll make a chart that shows the relationship between the various stages. So we have NAVD88, mean sea level, and GVD29, mean low water, and mean lower low water. And so we have some information that came from the NOAA benchmark sheets, which I've included over here on the left. And then the Corps of Engineers in New York gave us a separate one for the relationship for a given location. That's not Long Branch. But this is the information that we had for going between mean low water and NAVD88. So we use a combination of these two to develop the different relationships from going from one to the other. So the preparations for running the coastal modeling system, we're using a Cartesian grid, so it's a flat plane system. We normally run in state plane, but we can also run in UTM. We cannot presently run in geographic coordinate systems. So if you have information that's in geographic, you'll need to convert it to a flat plane system before you start the grid. The model computation, as it says, is in metric, and depths are positive from 0. So elevations which have negative headed upward have to be flipped to where the positive values are going down. Grid is generated based on a single bathymetry file stored in SMS. The vertical datum is usually not specified. You just have to assume that it's a local datum. Just make sure you keep track of what the bathymetry is that you've decided you're going to be using, whether it's mean sea level or mean tide level. Sometimes for larger domains, we may use NAVD88, some other non-local datum. But for a smaller grid, we typically use mean sea level or mean tide level. That means that all of the data sets that you bring in, all the different surveys, have to be brought in and converted all to the same projection, both vertically and horizontal. So for our case, we're going to be using Shark River Inlet bathymetry, and we're going to convert it state plane, New Jersey, in meters, with vertical datum set to mean sea level in meters as well. So when you come into SMS and use the interface, you'll get a dialog box that looks similar to this, and I'll go into and actually do a demonstration in a few minutes. But for right now, I'm just going to use this in the presentation mode. This is what the interface looks like. So you can say that my current projection I'm going to specify, and I'll set that projection to be whatever the survey was given to you in. So the survey came in NAD 83 feet. Then you would set that here, and then you would set what projection you want to convert it to on the other side, and we'll go over that in a few minutes. So in this case, we're going from feet to meters for zone 2900, which is New Jersey state plane. So as this says, CMS uses depths. I'll reiterate that because this is a common mistake that's made. People come in using elevations instead of depths. So positive values are down from the water surface deeper into the water. and it's easily transformed. Normally you just flip the sign, and then you can do any datum corrections, and this gives a little bit of information how to do that, and I'll show that in just a few minutes. So here are the various channel surveys that New York District gave to us. There's several here ranging from 1995 all the way to 2010. Of course, we didn't use all of those. We used a few of these towards the end, making sure that they covered the areas that we needed, and we combined some of these. So these came in to us in NAD 27 instead of NAD 83, so that's one thing we have to change. They also came in as feet instead of meters. We had to change that as well. The vertical came in as feet, and we have to change that as well. So for our conversions, for this particular case, we're going from mean low water to mean sea level. For the area as specified by the New York District benchmark sheet. And so to do that, we only knew how to do from mean low water to NAVD 88 because we didn't have information for mean sea level. And so we took that information and then we used the other benchmark sheet to remove the change from NAVD 88 back down to mean sea level. So we used a combination of these two sheets to get an answer that's appropriate. When we did that, we ended up with a value, a conversion of 0.841 meters that had to be applied to the channel surveys to bring in, and I'll show how to do that in a few minutes. So you would go, basically you would go into the dataset calculator. It's under Data, pull down menu, you hit Data Calculator. It brings up a toolbox that's shown here. It's hard to see, but I'll show in a minute. There's a data calculator, and it lists all the various items that are in your scalar tree. So there may be other things that are listed, but we're only looking at what's in the scalar data set right now. And right now there's only a Z, but it also adds in an X and a Y as well in case you need to use those for any kind of computations. So you would select that Z and you would type in an operation for that Z. So I think this was done incorrectly, but what we should have used was A, which is, it came in as feet. Okay, I'm sorry. They've converted already from feet to meters in this particular case. So they did a data set calculator with the Z and did an operation on that, multiplying it by 0.3048 to go from feet to meters. And they've come up with this separate data set here. So now we're using the meters to apply this datum correction of 0.841 to get meters and mean sea level. And so this is the location where you put the calculations, and this is the location where you put the dataset name that it's going to be called in the data tree. You would click compute and then done, and then it would show up in your data tree. So it's that simple. I'll go over that in a few minutes, demonstrating hands-on. So it'll be a little bit easier to see. I see a couple of questions. Okay. All right. So I'll move on at this point. So a different survey that we used for this particular case was the New Jersey DEP channel surveys. They provided the information in mean low water, and we were going, or they actually provided it in NAVD 88. Sorry. And we had to get it to mean sea level. So we had to do some operations there, and I'll go into that. The field data collection came in. It used state plane in 8083, New Jersey, in meters, and the vertical datum was NAVD 88 in meters. So all we needed to do for this one was to modify the vertical datum. We did not have to do anything for the horizontal datum at all. The Lidar came in, state plane, New Jersey feet, NAVD 88 feet. So we had to do some operations there. Coastal relief model is one location that if you don't have any actual surveys that were done, there is a NOAA site that you can go to that provides information in what's called the coastal relief model, which is just a conglomeration of hydrographic surveys and various other data sets that have been combined together in one big data set, and it's not generally to a certain vertical datum. We assume that it's close to mean sea level, but we don't exactly know what this is. So we normally only use this for a very basic background. I mean, if we have no other choice, then we would use this type of information. So as it's said here, it's not accurate for shallow bathymetry because we're not exactly sure whether it's mean sea level, what datum was used. You don't want to make any assumptions when you get very close to your project location. So only use this for offshore, deeper water, or in areas that you know are not dependent too much on an accurate answer. Then we also were provided a little bit of extra bathymetry in the form of a shoreline shapefile from ArcGIS. We brought it in. It had a certain value assigned to it of negative 0.75. We assumed that would be the edge of this water. So you see where that point came in. We brought that in and was able to merge all that together. And this slide just kind of shows how to bring in that data from the ArcGIS and convert it to an ARC within the SMS. I don't actually have the shapefile at this point. I just have the ending survey file as we want to bring in for SMS. So this would show how to do that if you had the shapefile from ArcGIS, which we don't. So you bring all of these files in, and you see they're all listed here in the data tree. So we've got 1, 2, 3, 4, 5, 6 different surveys that are brought in, and we've made the various adjustments to them. So we have a data set here that's mean sea level in meters. We have this already came in as meters in 8083. We didn't have to do anything to this one. We have the coastal relief model, which we made a modification to, these others. So we now have to bring them all in and put them into one data set. And some of them overlap and some of them don't. So we need to merge those points together. There's a couple different ways to do that. In this case, we bring the points in and we've cropped out the areas where they overlapped, and then we merged all points. So there's an option here when we go into the merge, whether to merge all the points or deleting by some kind of priority. And so you can use either one. In our case, we're going to be merging all scatter points. There's a question. Hold on just 1 second, please. I'm not sure if you guys can see the questions, that are being raised by the other people, but as we answer these, I'm not exactly sure how that's working, so if Alex could maybe reiterate the question if he's responding to all participants and then answer it, would be better. Okay. All right, so as I was saying, merging the scatter sets together, we're going to be merging all the points because we have deleted and kept the more appropriate information from the scatter set if they were overlapping. So I'm going to load in those scatter point sets from our data files and work with that right now. So follow along. This is not really a good environment for a true hands-on, for you guys to be working and us walking by like it is normally in a workshop. So if I need to go back over one of the options here or something that I'm showing, let us know, and I'll try to go back over it again and give more explanation if we can. All right, so what I'm going to do here, I'll shut that down, is to start SMS 11.0. So we'll go to the icon in the Start menu and start SMS 11, and you see it starts up here. And I had a zip file which I've unzipped, and I have a couple of files here in the bathymetry folder that you guys should have too once you unzip that file. And so what you can do is you could do one at a time if you want, bringing one in. All you have to do is grab it in the folder and drop it in the interface, and it brings up the file import wizard. You don't necessarily, for any of these, have to make any changes, but I'll go through and I'll explain a little bit about what it's doing. So there's a couple of different options here. One of them is whether it's delimited or not, and what we assume at first by default is that it's delimited by a space. And so you can see at the bottom here where the breaks will be if you make these choices. And this is pretty standard. This is a well-used dialog used in Microsoft products or probably some others. But anyway, just to go over it to be thorough, they may come in with a space delimiter or a comma delimiter. You never know, so you just know that this is how you bring it in. If you know exactly where that is, you can do a fixed width. You can also tell it to start importing at a certain row. If you have a lot of text at the top, it will identify that, and they'll be yellow up here, and they'll be skipped. As soon as it sees a number in the first column position, it will assume that's the beginning of your actual data to import. And you can include a header row or not, and if you check the box, it says that row 1, which I've listed here, is a heading row that has certain labels attached to it. And a lot of times you'll have this information will come in and it'll say eastings and northings and Z, or some other descriptive type of information. So normally you don't have to do anything at this point. You just click the next button and it'll take you to the next page. We have a scatter set is what information we're bringing in. We can give it a certain name so that when it appears in the data tree, this is the name for that. You see here is the header that I specified, and it always assumes that the first column is X, the second column is Y, and the third column is Z. It has nothing to do with the values that are on this header line. It just happens that they're identical, but that's not necessarily the case. So a lot of times you'll come in and you'll have your northings here instead of your eastings, which is the X direction. And so you'll have to swap these. And so to do that, you have a pull down, and you can say, okay, this row is actually my Y instead of my X, and this is my X instead of my Y. So if you need to make those changes, you can do that this way. In this particular file, these are in the correct order, X, Y, Z, as was shown here with this header. So I'll just click Finish, and notice that there's an option here to triangulate the data. If you have a very large Lidar set, say, and you don't necessarily want to take up memory space for that to be triangulated, you can tell it not to. So you would just uncheck that box and it would just bring in the points, but it would not triangulate between them. But in this case, we're just going to triangulate everything as we bring it in. A couple of other options that you can play with if you want, a tolerance, that if it's smaller or larger than a certain tolerance, then you would delete that point. But we'll just accept the defaults as they are, and click Finish, and it'll bring it in, and we see our first data set. Now you don't have to do these all at one time, one at a time. You can actually bring in, and I'm going to select the other 5, and bring in all 5 of those at one time. And it will process them one at a time in the interface. So now, like I said, we have a header line, X, Y, and Z. These are set correctly. We've given it a name. It always defaults to whatever the name is before the .xyz or the .txt. We'll click Finish. It'll come in. It's put it into the data tree, and now we have our third one that we're going to be working with. So this shows XYZ. There's a certain number of points. Now we're not going to make any kind of horizontal projection changes or anything. We're just bringing in the data. We have to know where that data is and what the projections presently are, and we'll change that later on. So you notice that these are -73. This is coming in geographic coordinates. So we'll click Next, XYZ, Finish. Okay, we got a message that said we have 43,000 duplicate points. That's basically because since these are in degrees, only 3 digits were provided as the tolerance or the amount of precision for this. And you notice that on the second and third line here that it's exactly the same value, 73.588 and 40. So luckily this is for some underlying bathymetry and we don't need all these points. So we'll just click OK, and we'll move on to the next data set. All right, the next one comes in. I'll just click these, X, Y, Z. All of these are in the right format, so you can just click through to finish on each one of these. You would realize relatively quickly when you reach a problem. So I'll kind of show in a minute what I'm talking about here. So we'll just XYZ, Finish. All right, it's read all the points in, and now it's triangulating. So we're at the next data set. All right, and we have got all 6 of these loaded, and we see our screen here. So if we zoom out to everything, which is what this second option here does, click Frame. Frame normally expands the screen to encompass all the loaded data. Now you can turn some of these on or off, but we can see that the data that we have, there's one little piece down here in the lower left, there's one here, and up in the upper right. we can see that there's 3 different coordinate systems, 3 different types of datum horizontal corrections that we're going to have to make here. If we zoom, and this is the zoom tool, excuse me, we can draw a box around this one here and zoom in. All right, and I'm just continuing to zoom, and we see that looking at the lower left-hand corner here, that this is the one that's in geographic coordinates. You notice that the color here is like a green. What that means that if a certain data set is selected in the data tree, its color for points should be red. So I'll look and see which one this corresponds to, and it's the coastal relief model, lat long, meters of mean sea level. So you see it turned red. That says that this is the active data set. All right, I'm going to frame again and go back to all these others. So we have one set here, and another couple of sets here. Normally, if you see them, just a quick tip to help you figure out, sometimes you get this data and you don't exactly know what the metadata is. You don't know that it's a certain coordinate system. Or you may have been told one thing and it's actually a different. If it shows up and you get this relationship where one is in the lower left and one's in the upper right, normally what that means to me is that it's a difference of horizontal being in feet as opposed to horizontal being in meters. So it's a factor of almost 3 in both the X and the Y direction, so it kind of puts it in this type of situation. So what I'm going to do is, for this coastal relief model, the very first one that's down here, we know that's in geographic coordinates. So first thing that you should do is, under Edit, is come in and look at the projection, and that's not reprojecting anything. That's setting what you want the data to end up in. So you have made a conscious decision that for this project, I'm going to be working in, and I'll set the projection, state plane, NAD 83, and I'll switch this to New Jersey. Let me find it. Here it is. And make sure that it's in meters. All right. And so click OK. And we'll assume that for this particular case, our vertical is in local projection, which just means it's a mean sea level or a mean low level water, some non-regional or national projection in meters. So I'll click OK, and now that's set, and so I don't have to worry about it again. So what I can do is, for each one of these data sets, I want to change the projection from what it's in currently to what we want it to be in. So each one of these, you would right-click. Well, first you would select it by left-clicking, then right-click and tell it to reproject. So we would reproject this one. What we just set by the projection is over here already. We don't need to modify this at all. We can scroll down and see that it's meters zone 2900 in 8083, so that's what we want. What we want to change, though, is that this particular data set is in geographic coordinates. So we zoom through all these list of different projections, and they have tons and tons of them in there. So just go into the geographic, find that, and click. It comes up with the datum of NAD 83 arc degrees, and that's fine. You just click OK. So now we want to make sure that in the vertical, we're only changing the horizontal units right now. We don't want to make any change right now to anything vertical. So to ensure that, we make sure that the projection that's shown on the left is the same as the projection shown on the right. So we'll just change this to meters. once we click OK, it'll go out there and convert that geographic coordinates to state plane. And you notice that point way down in the corner has moved, and it's now right here. All right, and so let's look and see what this is up here. So I'll zoom in. We see the values here like 600, 456. And we'll try to find that one. Okay, here's one of those data sets. So this is actually specified. Let me make sure I'm doing this right. This is specified in feet, and we want to convert that to meters. And so what we do is we right-click, choose to reproject, change the global projection, and it's already in state plane, which is here, New Jersey, but it's in feet instead of meters. All right. And so we'll change this to meters just because we don't want to make any kind of change until later for the vertical. I wish they would take this option off of this menu. But now that we have this set in feet and this is in meters, we'll do the reprojection, and that has disappeared and it's now over here even though you can't see it. So the same thing for this other one right here. So I'll make that same conversion. So we do a reproject, global, change it to state plane, and change the units from meters to feet. All right, so I've got feet and we're converting to meters. I click OK, and it's going to take a second because that's a Lidar set. And it moves down here, and here it is. So you have one more data set that we need to convert horizontally, and that's this one. So we do the same thing again. Reproject, global projection, state plane. We want to go from feet to meters. And now all of a sudden, everything shows up in the same screen. All right, and I'm just looking at the different individual ones. You can go into your display options and change the size of your points if you want to better see what's going on. You can look at contours if you want instead of the points, but the main point of this exercise was to convert all the horizontal units from feet to meters, and also to go from geographic over to state plane meters. So we're about 15 minutes before the end of today's webinar, so I'm going to stop here. And is there any part of this that I need to go back over? I see one question right now. I don't know if it's been answered or not. Okay, a question was from Allison, where we could register for next week's webinar. And I'll send a link in just a second here. So this is the link that you would go to, and I'll send this to everybody in the audience. Are there any other questions before we wrap up for today? There's a little bit more that we could get into, but I think it's going to take us past the 3 o'clock, and we do have people from various time zones, and I know some are from overseas, and it's probably very late there for them. So if there are no more questions, you guys can start to leave for the day. We'll pick up tomorrow from this location, and we'll go forward. If you have any questions that you want answered, you can email them to me. In the earlier presentation material, I provided my email address as well as some others. And so you can email any questions, and I'll try to answer them tomorrow. There's another question to reproject. We need to know the datum for the data set. For a horizontal projection, what you need to do is you may have a choice between, let me go to the screen here. Your choices, sometimes you may have some data and it was in NAD 83, it may have come in NAD 29, I'm sorry, NAD 27. That's the only datum that you might have to switch between for the horizontal. For vertical, that's a totally different story, and we're going to discuss that tomorrow. And hopefully that answered that question, Julia. Today's presentation slides, as I said, are on our website. I'll give the link to you guys. And basically, if you look down on the agenda, there's a list of the presentations. So there's the welcome and the 4 different presentations. I don't have one for the hands-on that I did, the demonstration, but then all the data is listed here. So you just click and then you're able to download to your desktop. Another question is there any international bathymetric data for Egypt in NOAA? My guess is probably not. You never know. The NOAA site, I'm trying to remember the name, you can go to, it's called tidesandcurrents.noaa.gov, G-O-V. And that has, it looks like they're showing a map of only the United States. So my guess is that NOAA does not have data, bathymetry data for Egypt. I'm sorry. There will be no video as far as what I've been covering on my screen. There's only the presentations, a PDF of the presentations that I did earlier, but the audio will be presented later. I know that's a little unfortunate, but we will be trying to provide some animations of us going through this. We'll try to make some recordings and post them at some later time. We're trying to get that done by the end of the summer. One of the other questions was Google Chrome and Internet Explorer. Allison cannot see a form for the June 18th through 22nd webinar. So if you go to, my screen's locked up. Okay, here we go. Hold on just a second. If you go to webinars in the 18th through 22nd June, down below in the registration area, there's a link to register for that webinar. And so if you click that link, and I'll go ahead and try to select it too and post it for you guys. You can go to that webinar registration page, and this is what it looks like. All right, so this is the advanced topics, and it's next week from 1 to 3, the same times on the same dates. It's a little bit more information for you to fill out. And I'm sorry if you had already registered through the other page. I've moved everybody over to the GoToWebinar registration. This is only for new people to register. Thanks for the compliment, Jennifer. It's good to know that the pace was okay. I tried not to go too fast, and it's really strange not being able to hear you guys. So I just wanted to make sure that I talked clearly enough, especially after you could hear me, to cover everything that we went. All right. Another question from Patrick. He says, can we know the projection if you don't know the information? And that's really tricky. Sometimes if it's geographic coordinates, you can tell that they're degrees, and so you kind of have an idea of where that is. Otherwise, you're really on your own. You hope that if you're working in a project and somebody gives you some files, you hope that that is in at least a local UTM zone or a local state plane zone, so you have a general idea of where it's located. And the only question then might be whether it's in relative to NAD 27 rather than NAD 83. And those two datums are just a little bit off. One's a little bit skewed from the other. It's really tricky if you are not given any kind of information where to get that data from, or how to know where you are in space. Are there any other questions? I can go over anything that you guys have seen so far today. If not, I will see you guys tomorrow. I will stay here until 3 o'clock answering any questions that get posted, all right? You're welcome, Patrick. Okay, to import the data into the SMS GUI, I'll cover that again. So we'll start the SMS 11.0. And there's different ways you can go about this. I don't know why it's taking so long to start this. Okay. There's different ways. You can, normally what I do is I'll just open a folder and I'll grab all the data and I'll drag and drop it into the interface. There's also you can see a folder open which opens a folder here. You can do file open. There's several different ways of bringing in the data. The other question is, does it matter if you're using 32-bit or 64-bit? And no, it does not. The only place where that might play a role is if you're loading an extremely large solution, maybe. A 32-bit computer can only have so much loaded into memory, so many pointers and everything used. And so sometimes we've seen that a user using the 32-bit version of SMS may not have access to all of the simulation that they're actually ran. It'll stop after a certain period of time. And the only way around that is to either don't output so much or to use a 64-bit version of the SMS. I'm not sure of your question, Ahmed, regarding using SMS with shallow water modeling. Is there any paper deals? I'm not sure what you mean by that. I can go to the Aquaveo website and show where their page is. So it's www.aquaveo.com. All right, and this is the vendor that sells the SMS, and they also have GMS and WMS. And there's more information on their products. There is pricing information. So let's go to SMS. There's editions and pricing. And so this gives a little bit of information on what's available and what the costs are. And then there may be some information, like it says, for academic and multi-copy and training discounts. So your best bet, Ahmed, is to just contact Aquaveo with a email, and they'll try to answer your question. As far as, Taylor, you're asking, will I be going through the physics of the modeling suite at any point? I'm not going to be going through any of that during the basic webinar, but that might be something that Alex would or will or could go through next week. He will actually be giving that webinar, and so any questions like that he'll be able to answer. All right, for reprojecting, I'll just load one data set in real quick and just show you again, Molly. So I'll just load this coastal relief model. All right, and so the first thing you want to do is to go in under Edit and set your general projection that you're going to be using for your grid. And so what we want this to be in is NAD 83 State Plane, New Jersey meters. So let me find New Jersey. All right, and that isn't changing anything yet. That's just setting the overall projection. So now we want to reproject this coastal relief model. So we'll right click and we'll say reproject, and we'll say, okay, well, this coastal relief model is in geographic coordinates. So I'll set the global projection and I'll click here for projection, and I'll scroll through the list until I find geographic. And then I will click that. It'll set that and change these datums to whatever is appropriate. Click OK, and then the vertical we're not going to change, so we leave it identical to what's on the right hand side, which is meters. You click OK, and instead of being in -74 degrees, it's now changed that, and you see that these values have changed now to a meters based instead of a degrees based unit. I hope that answered your question. So Ahmed, you're asking if based on a single application what a cost of the interface might be. If that's the case, they don't do that. They don't sell a short license or anything for a general, like for one project or anything like that. Basically what it is you buy a license and you get unlimited updates through the end of that year or until the next major release of a version. So if it goes from 11.0.1, which is just update 1, to update 10, you'll always get those for free because you bought 11.0. But you don't necessarily get the upgrade to 11.1 that would happen the next year. I hope that answers your question. As far as what you might be able to do on a short term getting a license, all we can do as far as trainers and instructors are to give out a temporary license on a training basis, and the maximum term for that is about 2 months. So we're really restricted in doing that. All right, well, it's after 3. I'm going to conclude for the day. I will see you guys tomorrow at 1 o'clock. One last question from Patrick. WSE is just shorthand for water surface elevation. So basically, if you know what the water surface is doing, then you can force your model with that information. Any other questions, please give me an email and I'll try to answer them as I can. I've still got to prepare for tomorrow's webinar, but I will try to answer where I can. If not, I'll try to cover tomorrow. All right. Thank you guys, and see you tomorrow.